So, Homo sapiens, the wise human, that is us. Even though we quite often do quite a few stupid things, but that is another story. So, Homo sapiens. Homo sapiens is characterized, as you can look by, you can check by looking at the mirror very quickly. We have a relatively high forehead, very flat face, large brain, and the fact that you can look into a mirror and you listen to this, to what I'm talking right now, we have a pretty sophisticated cultural tool set. One of the interesting questions is how old we are as a species. Old estimates were that we probably emerged sometime around 200,000 years ago in East Africa. So that was the common kind of assumption. But as recently as June 2017, there was some evidence of some Homo sapiens in Morocco, so in North Africa, in these caves, found in these caves, that were 300,000 years ago. So it is remarkable because this finding of this Homo sapiens skull shifts us back about 100,000 years ago, and like a few thousand kilometers away from where people had thought previously that Homo sapiens first emerged. So um, don't expect this to be the last news on this. Most likely Homo sapiens evolved probably in the time span of 300,000 years ago or thereabouts in parts of Africa. Potentially we had multiple lines of humans that evolved and interacted with each other in different parts of Africa. It's a story that will be continued probably, and if you check in, let's say in a couple of years, we might have more information on this. So, Homo sapiens, probably 300,000 years ago, somewhere in Africa, and we are the group of humans that has the most complete, sophisticated set of social tools. And we now have evidence that humans moved out of Africa a few times, multiple times, through a number of different routes. So first migrations out of Africa most likely happened over 100,000 years ago into parts of Asia. So, like along the coastlines again, along the edges of different food webs, so where you have access to maritime food, as well as terrestrial food sources along the areas, for example, bushline, savanna, or tree line to, like upper, like above the tree line food sources, as you can see here, into the Himalayas. So our humans were traveling back then very quickly, very fast, very efficiently over long periods of time. So most likely we had multiple waves, migration waves. The interesting thing is that us humans who are around today, we are descendants of a later migration waves, which happened around 50 to 60,000 years ago. We don't know what happened to these earlier humans. They may have disappeared because of the very harsh climatic environments. You have to imagine small groups that moved across the world, and some of these groups, being so small, may not have survived in these harsh environments. We might have been killed by other hominin groups that were around, and we will talk about some of them in just a second. Or it could well be that our later ancestors that moved out of Africa around 50 to 60,000 years ago may actually have killed our older ancestors off. We don't know. Fact is that we are the descendant of a more recent wave of migration that happened about 50 to 60,000 years ago. But voila, we took over the world. We moved all to pretty much all continents except Antarctica over the next couple of thousands of years. And if you think about it, we moved out of Africa about 60,000 years ago, that last wave of migration, and within a time span of about 10 to 15,000 years, humans were able to get all the way down to modern day Australia. It's a pretty amazing feat, if pretty amazing achievement if you think about it. An interesting aspect is, as humans moved across these various different geographies and climate and vegetation zones, the food that became available to us also changed quite a bit. So if you look at just modern human groups, for example, the Gung and the Hadza in Africa, or the Hiwi in the Amazon basin, or the Inuit up in the far north, the extent to which they depend on different food sources varies dramatically. So for example, the Kung, they actually depend much more on seeds and nuts in fruits and vegetables compared to meat, whereas other groups are much more heavily dependent on meat. So what this suggests is that our ancestors were able to extract food sources in a very efficient way in the local environments. And they also took advantage of, for example, different carbohydrates, so wheats, grains that are around in different parts of the world. And what you need to think then is that our ancestors, now living in different environments, face different selection pressures. Food is probably one, and anything related to diet, so basically getting energy in the most efficient way, is probably one of the most important survival features. So most likely genetic adaptations, directional selection would happen for our ancestors in specific environments to make the most out of the locally available food, and of course also adapt to the environment in terms of, for example, how much sunlight is there, how much oxygen is there. So for example, if you live in the lowlands or in the highlands, and the ability to deal with local parasites and local diseases. So what this review paper by Sarah Tishkov's group suggests is that humans adapted genetically to these different environments, and we see lots of different adaptations in different parts of the world, often in a convergent manner. So for example, if we look at, for example, our skin tone, right? It's a polygenic effect, so lots of genes are involved, but what happened is, as humans moved further north, both in Europe but also in Asia, what happened is we had to extract extract vitamin D, right? So there's less sunlight around, and so if we would have kept our more pigmented skin, we would have been less able to synthesize vitamin D, which is very important for bone development, and it also is really important for our immune system. Imagine living in these colder, more hostile environments, and we need it for all sorts of other inner organs like the pancreas, the brain, and the heart. So there would have been an advantage for humans to have less pigmented skin, so lighter skin, to extract these UVB rays from the sun in order to create vitamin D. Of course, this now is not necessarily very good for us, because UV the sunlight, UVB light, causes us to have sunburn and get skin cancer, right? So even though It increases our ability to synthesize vitamin D. So very early on in our life, we're healthier, right? So we can reproduce better, right? So we're healthier, we have more offspring. At the same time, later in age, all these this exposure to, like to sun, sunburn, increases our risk of getting skin cancer, right? So even though this polygenic change to having a lighter skin tone is advantageous earlier in age, it sets us up for a risk of having skin cancer later in life, right? So basically, it's a balance, it's a trade-off. Other examples are, for example, as people um, moved into um, tropical areas. Tropical areas, so we evolved most likely in Eastern Africa, in savannas, open grassland, and as our ancestors moved into more tropical environments, like tropical forests in both Africa as well as in Asia and in South America, for example, in the Amazon basin, there were a couple of adaptations again to deal with these very harsh environments. These tropical environments are very, very tough. So the first thing that you will notice that a lot of humans that have adapted to living in tropical jungles are shorter. So they have experienced a reduction in body size. The most likely explanation for this is these forested areas are, very hard. It is, believe it or not, if you look at all these films, it always looks like there's all this food around. It's actually quite difficult to extract food in these tropical forests. There is relatively little nutritious food around. It takes much more time to stalk or hunt animals or find probable food sources. So a smaller body size is actually adaptive because you need less food to grow, and also because it's a very hot environment, you can more easily deal with the heat stress by having a smaller body. And so again, there seem to be some kind of evolutionary trade-offs that changed our body size to become smaller for those individuals that moved into these tropical areas, and with these shorter stature, there was also, it was associated with, basically an earlier cessation, stopping of growth, and so then an earlier reproduction age. So living in this very hostile environment and being exposed to all these parasites, diseases, these like the lack of food, for our ancestors moving into these environments, it would have been advantageous to stop growing earlier and have children earlier as well, because then you would pass on your genes, and you make sure that some of your genes will survive. So at the same time, there were also upregulations in various genes that are associated with immune system functioning. For example, there are genes like with these beautiful names like CISH or HESX1. And so these immune function genes were upregulated in these human populations that are living in tropical areas. And some of these immune function genes also, so again, this is where pleiotropic effects are really important to understand. These genes also influence, for example, the functioning of growth hormones. So it upregulates, these genes upregulate the immune function, downregulate, for example, the growth hormones, and therefore have some effects across a number of phenotypes that help individuals to adapt to these environments. So very important to understand, again, the idea of pleiotropic and polygenic effects on our human ancestors as they moved into different environments. And to make things even more interesting and complex. There are things like, for example, sickle cell um, disease. So this is something that it's a mutation that reduces the ability of our red blood cells to carry oxygen because of a deformation of the rate of the blood platelets. At the same time, though, if you are, so this is a recessive feature, recessive allele, right? So if two of these recessive alleles come together, you show the disease. If you are heterozygote, though, so you have a so you have one of these recessive alleles, you don't show the disease, but at the same time, it gives you protection against some diseases like malaria that are very common in African tropical zones, right? So an adaptation like this, where even a genetic disease becomes advantageous because in a heterozygote state it protects us against a very potent parasite that kills over 1 million children each year, even today, is a very significant selection pressure. So this is, like, just to give you an example, like our migration into these different areas required different genetic adaptations in our human ancestors, and these adaptations are locally beneficial, but actually may like have all sorts of side effects. So this is again just an example that selection, natural selection, evolution is blind, and there's no free lunch in evolution. There's no like evolution towards higher, better complexity. Evolution just works to make sure you can pass on your genes, and you pass them on with the like least minimal damage or effort in a specific environment. And don't get me started, some of the stuff that I just saw like in the last couple of days where people were ranting about, for example, the necessity to wear masks in places like the US, and using evolutionary arguments to say that like if masks would be like important for us to survive, we would have developed them evolutionary. So that is a whole like this is basically a nonsense argument where people don't understand how evolution works. And like the fact that evolution like is a long-term adaptation to the environment that you move into, and then those individuals that are more likely to pass on their genes, so the adaptations need to be in place for like early in life to pass on your genes. So if you think about, for example, the COVID um, virus right now, the way it affects mostly elderly people, most likely it would not actually be an evolutionary salient mechanism that would immediately drive a natural selection pressure towards like a resistance towards COVID. Most likely not, because it affects people above a certain age, which evolutionary speaking was past that time when people would have had children, right? So you have to think about the evolutionary pressures in specific environments. So this also, like discredits, like a lot of these things that people believe about what our environment was like, and that there was one specific environment which we adapted to, and therefore there's one size fits all. This is not the case. This beautiful book by Marlene Suk that kind of discredits a lot of what is about in the media about like what evolution might have done to us. Evolution works in very complex ways and helps us to adapt over a long period, sometimes hundreds and or most likely thousands of years, to specific pressures in an environment. So this is what we have to remember. Evolution is blind, and evolution does not work in a goal-directed way. Another thing though that happened to our ancestors was the ability to create more sophisticated and more elaborate tools as they moved around the world. So we already mentioned, like we had clothing, we had art, we had all sorts of complex tools. So we had compound tools where we would now put these axes, like these hand axes that Homo erectus had, and combine them with a wooden stick in order to have a more efficient kind of axe that would extend the length of our arms actually. So we had all these kind of tools and symbolic representations. We have the first kind of figurines emerging, and even things like, for example, stone flutes. As humans were moved into Europe around 40,000 years ago, they had time and energy to create these bone flutes that were tonal. So you can actually use them and play melodies on them. In terms of the sophistication, the quality of these bone tools, bone flutes from 40,000 years ago, they are quite similar what humans used in the medieval ages. This is mind-blowing if you really think about it, that 40,000 years ago, our ancestors, like with very primitive tools, knowledge, were able to build little flutes out of bones that would be useful for playing little melodies. I think this is really an amazing, like, it's just amazing. Nothing else to say there. But the question is, were we alone, and what were the consequences of potentially having lots of others? That is the next section.